Enhanced automation with WebDriver I/O, time travel paradoxes, and broken promises. JavaScript and, by definition, TypeScript are insanely fast programming languages because its primary goal is to build your website page as fast as possible. Now, the way it does this is by executing its code in an event loop with multiple threads. Now, this is a fantastic advantage when you're trying to build your web page, but it can be a hindrance in test automation that needs to execute events in a particular order. Now, we can see this in action by right-clicking on the browser, selecting Inspect, and opening up the developer view, and then clicking on the Network tab. Now here we can see the name of all the resources that are being downloaded, their statuses, the type of elements that are being brought in, and particularly under the waterfall you can see how long it's taking to load those resources and in what order. And here's a quick tip. If you ever see something in red like this, that means something's gone wrong on our page. Take a screen capture and show that to your developer. So this speedster is so fast, it can look like it time travels. Let's take a look at the Chapter 4 suite of test cases. It has 3 test cases in it, and we're going to walk through the very first one, which demonstrates the time travel paradox of JavaScript and TypeScript coding. So here's a quick tip that there are 3 tests in here, and if I run them, all 3 will run. But if you wanted to just run one of them, you don't have to do this. You don't have to set the describe and comment it all out like that. That's one way. But the faster way to do it is just to put an F in front of the it. That means focus on this test, focus on it. And now the only test that's going to execute is this one. Let's take a quick walk through what's going to happen here. We're going to create a promise and resolve it immediately, and then it's going to print out promise micro task, and then we're going to set a timeout, and it says set timeout, which is a macro task. And then third, we're going to do a console log that's going to print out main thread. So let's go give this a shot. All right, test case passed. And what did we get out for our output? It says that the main thread number 1 executed. This is the main thread over here. It's our third line. In fact, it says the third line of code executes first, which is actually what it did. Then it goes and says the promise micro task was executed. Well, that's our first line of code, and it was actually executed second, exactly what we said it was going to do over here. And then third, after we actually complete our suite, is when this third line of code executes out. And it says we set a timeout, and that is our second line of code, but it executes last.
So you can see, this is where time travel becomes a real problem for a test automation engineer.
Yeah, thanks, Doc. Now, to understand why that occurred in that order, we have to understand the JavaScript event loop, because there are essentially 3 levels to the way this executes. Our test executes and starts first, and regardless of what we may have done, setting up a promise or setting a timeout, the first thing that always executes is whatever's in the main thread in our first loop. As we execute that loop, the second thing we do is execute any microtasks that happen, which was the promise, which means that's why line number 1 executed second. And then as we come around to macro tasks such as callbacks and timeouts, that's why our timeout over here is going to execute third. There's nothing more left in the main thread, so it finishes. So the point is in order to try to keep everything working fairly well, we always want to have our functions as async functions and always have awaits. In this case, this is our test. We're going to let this run and execute. Now this is going to bring up our browser jump to our login screen, put in the username, the password, and verify that we did see a good message. We can see that we focused only on this test, so 2 were skipped, 1 is passing, and we also have some of the cool extra stuff that we'll be talking about in our upcoming chapters outputting this. But essentially what it did is it went and found all the information we needed and output it in the correct order. Opened it up, logged in, and went to existing. And if we go to this login method, we'll go to the definition. We see that this is an async method, and it is using await to set the value of the username and the password, and then clicking on these elements as it goes. But what if we weren't to do that? What if we got rid of the async and we got rid of all the awaits? What if we did it this way? We open up and say we're going to use a global log over here and say that we're going to open the browser without awaits, just to say what kind of test we're running there, just so we know which one it is. We're going to go and open, but we don't have our await here. In fact, if I go to this definition, you can see that this is an async, and if we go to our open, it's also async and is using awaits in order to execute the navigation, but we never put the await in front of that open. So what's going to happen? Here's another one. We actually have a custom version of our login method, and what that custom version is doing is there's no async and there's no awaits. It's just putting it in as fast as possible and performing our click. And there's no await before the expects. So these are also going to be executed in whatever order we want. What do you think is going to happen? Let's give it a run. It passed. But why? Let's go into debug mode. We're going to put a stop point here and give it another run. So our browser is open and ready to be navigated. Well, wait, was it navigated? We're going to input the input username, but there's nothing there in that browser. Then we're going to go click and expect to get our flash alert, and expect that the flash alert contains you are logged into a secure site. I assure you, it didn't do any of that. See what happens when we slow things down? Time gets really, really weird when we don't have those awaits. So let's fix a little bit of this. Let's put the async in there, await that open, and give it one more run. Now everything should work perfectly fine. Let's take a look at our browser. And now we've gotten to the login page because we awaited the login. Now we're in the login sync, and we're going to run this. Let's put this in step by step. So we outputted saying we're logging in over here using our global log. And I'm going to go and enter in the username. But the username wasn't populated. Okay, what about the password? Password wasn't populated. Why is that? Because these lines are going to be executed in different threads, and they may not actually execute in the order we think it's going to be. We're going to go and hit the click. Nothing was done. Now, if we execute out, we'll verify that we see an existing flash alert, and that it says you are logged into a secure site. So it looks like nothing got passed in. So to fix this, we're going to await over here on our expect validations. Let's give this another run. to be sure, this isn't populating at this point because we are in a different thread. But now that we've appended the await in front of our expect statements and let them execute, check out what happens next. Our login page has populated. Well, we failed now because we expect a text to have text containing you are logged into a secure area. However, we got a response that said your username is invalid. And why the username is invalid is because we executed these in a different order. The click was performed first, then the username, and then the password. The ultimate takeaway here is that this is not an issue with WebDriver I/O. This is the nature of the beast with JavaScript and TypeScript. One last item of note, there was a project called Fibers, which was really cool. Syntactic sugar that took care of all the async and awaits behind the scenes. The problem was that by April of 2021, it had become incompatible with Node.js version 16 and had to be abandoned. So if you ever happen to see a message like this that packages are looking for funding, please consider supporting your favorite Node package projects.